Hello everyone, I'm Bingzo. Welcome back to another video. So in this video, we are going to be finishing up all chapter 3. Yeah, technically chapter 3 is a very short one. I think we just have 2 videos. Alright, so one video that I'm going to upload it, I think one day before this. And today, the agenda for today will be, number 1, we are going to be looking at, number 1, we'll be looking at equation of a straight line. Alright. And after that, we'll be looking at parallel lines. All right. And then lastly, we'll be looking at perpendicular lines. All right. So this is going to be a little bit longer, I expect. All right. So let's go into it. All right. Number 1, straight line. All right. And the equation, the general equation is given as y is equals to mx plus c. So this y is the y coordinate, all right? X is the x coordinate, all right? No problem. M, from the previous video, we say m is representing the gradient, okay? And c might be something new, which is the y intersection point. All right, so how does this general equation of a straight line make sense to you? Okay, so I can explain this in the coordinates of y will be equals to the gradient. Okay, the coordinates of y will be due to the gradient multiplied with the x. So for every single change in x, you will get the corresponding y. So the gradient with x and then with the height of the slope. So c is the y-intersection of the graph. So if we are going to be giving a little short example here, something like this, and then we will have a straight line like this, and this is a 5. Then by just reading from the graph, we know that the y-intercept point is 5. So c will be equals to 5, and this is the height of a line. Why will I name it as the height of a line? I'm not sure if it's an official term or any other place would name this before, but I will name this c as the height of the line because if you have got a line like this, okay, and we always name this as y equals to mx, all right, because c touches the origin, c equals to 0. So when the line crosses the origin, c is equals to 0 and there is no height for the line. All right, so it's just y. The y value would depend on the slope of the line and the x coordinate of the line. All right, so it's just a simple overview of an equation of a straight line. All right, so this is actually what is stated in the syllabus content that you will need to know is how to interpret a straight line. All right, so the general equation straight line is y is equals to mx plus c, for y is the coordinate, m is the gradient, x coordinate plus with the y intersection point. Okay, so there are other ways of stating a straight line. If I'm not mistaken, there is one way. It's called the y minus y1 is equals to m x minus x1. Yeah, I remember there's one type of straight line equation which can be written as this, so that you can actually, it's easier in some cases but not all. But I hope not to say something that I'm not confident of here. So in this video, I'm just going to be using the general equation because this is what I know. And this is something that I'm not sure whether it can work in IGCSE or the name of it, because I don't really remember names of a lot of stuff. So yeah, I'm not going to be talking anything about this form right here, whether it's a gradient form or intercept form. I remember something like that, but yeah, let's just ignore it. Okay. So the first thing here, I had told you how to interpret an equation of a straight line. And the second thing is, you will need to know how to obtain. All right. The question now is how to obtain. Default colors can be okay. How to obtain the equation of a straight line from given coordinates. All right. So one quick question for you to think about is how many coordinates is needed in order for you to create a general line, in order for you to create a straight line formula. All right, you can pause the video and think about it, okay? And you can resume after you have got your answer. Okay, so if you think about it, an equation of straight line consists of 4 elements: y coordinates, x coordinate, gradient, and y intersection point. So you can see all these here, y coordinates, well, it's just y coordinate is something that you want to get, and x coordinate is something that you input. All right, so this two can be any value, so it can be 1. 1 coordinates is enough. 1 coordinates of x can give you the coordinates of y, all right, and vice versa. C is the y intersection point. There is only one y intersection point in every single straight line equation, which means there can only be one value of C. And now it comes down to gradient. All right, if you haven't already watched the previous video and you don't know how to find a gradient, I would suggest you to go to the previous video to look how to find the gradient. So gradient, the equation of gradient is y2 minus y1 divided by x2 minus x1. This is the barely minimum thing for you, barely minimum condition for you to look for a gradient, which means you will need at least 2 coordinates. So all these things here, you will need at least two coordinates to form a straight line. Okay, you will need at least 2. Okay, this is something that you need to remember. Okay, you will need at least 2. Okay, so I'm gonna be erasing all this because I'll be compiling it as a note to post it on Instagram later on. So you will need at least 2 coordinates to form a straight line. This is the first thing that you will need to know. And there are a few steps to do it. So step number 1 is let's use another color, should we? Step 1, of course, find the gradient. Okay, the first thing, you will find the gradient and you will write it in terms of y equals to mx plus c. Then step number 2, find y-intercept, all right, which is the c. Then you will get your equation of a straight line. Okay, so from the previous video, I'm pretty sure, how do I do this? Okay, so from the previous video, we have used an example of, okay, A is equals to, I really can't remember, 10 and 7, and B is equals to 2 and 3, I guess. It's something like that. Okay, so I want you to, we want to look for the equation of a straight line. Okay, so to follow the steps that I just said just now, step 1, we find the gradient. Okay, which is m is equals to, we found it from the previous video, which is m equals to 1 over 2. Okay, so we will move on to step number 2. So step number 2, find c. How do you find the y-intercept? Okay, so first thing first, you're gonna list it down, y in terms of mx plus c. Okay, this is the first step. Then the second step here, you sub in the n value that you get just now. Y equals to half x plus c. So number 3 is you can sub any of the given points. All right. Say in this case, we will sub 10 and 7. Okay. Which you will get y is equals to 7 equals to 1 over 2 10 plus c. And therefore, you will get your c is equals to 2. All right. So number 4, you will get your equation of straight line to be y equals to half x plus 2. And this is how you get the formula, the equation of a straight line. If you can double check the equation of your straight line. All right, you can double check. I'm use a different color. This color here to check. Okay, y equals to 1 over 2x plus 2. Okay, since this is coordinates A, we are going to be subbing in at coordinates B, which is 2 and 3. All right, so when x is equals to 2, your y is equals to 1 plus 2, which is equals to 3. And this actually is equals to B, 2, 3, which means this equation straight line containing A and B is correct. All right, so this is how you look for an equation of a straight line. All right, so the first two agenda, we are done. Okay, we looked at how to interpret a straight line and how to look for an equation of a straight line. All right, easy, nothing hard. Okay, next we'll be looking at an equation of a straight line parallel to a given line. So first thing first, we need to know what is the definition of parallel. Parallel is I regretted that. The real definition, I don't know, but the one characteristics of parallel lines are they have the same gradient. Okay, they never touches. Okay, which means there is no intersection point. Okay, so these are the two main characteristics of parallel lines. So in short, they are going to look something like this. Okay, so they go straight, the same gradient, and forever. Okay, unless given domain. Okay, so how do you look for an equation of a parallel line from a given line? Okay, so from the syllabus content, I had taken the example that the question is ask you find the equation of line parallel to y is equals to 4x minus 1 that passes through, oh dear, I don't need antivirus protection. Just kidding. Don't come and hack me, alright? That passes through point 0, negative 3. Okay, so don't be frightened if you saw any questions like that, because we're going to be interpreting it one by one. Okay, so first thing first, they want you to find equation of line that is parallel. Okay, once you see this parallel, then you need to recall what are the characteristics of a parallel line. Same gradient, no intersection. Okay, so they say parallel to this. Okay, so both of them are parallel. Okay, so this is like a symbol of parallel lines. Not this. Okay, the symbol of parallel line is just like this. So they are parallel. And then the equation of line needs to pass through this point. Okay, so I'm going to be drawing out in the diagram so that you can visualize it better. Okay, so there is a line y equals to 4x minus 1. So it's positive gradient and minus 1. So the line goes something like this. So this is y is equals to 4x minus 1. Okay, so now they want you to look for another line, which is number 1, parallel, which means they have the same gradient, and needs to pass through the point 0 and negative 3. So to extend this, oh dear. Okay, so to extend this will go up to, oh no, let's redraw this, yeah. Okay, so this is gonna be negative 1. So now they want you to look for another line that passes through 0 and negative 3. So 0 is the x-axis, the x coordinates, and negative 3 is the y. So which means you need to pass through here, and the line must be parallel to this line, okay, such that this two is parallel. All right, so this is the symbol saying that it's parallel. So how do you look for this one? Okay, so we're going to use back the same steps to look for an equation of straight line. Okay, from the previous part, we have step number 1, find the gradient. Step number 2, find the y-intercept. Okay, it's easy because from here, we know that, okay, you can first list down step 1, find gradient. Okay, and it's easy because we know that since they are both parallel, the let's name this line C, and this is line D that you're looking for. The gradient of C, different color. The gradient of C is equals to gradient of D, which is equals to 4. All right. If you recall how to interpret a straight line, y equals to mx plus c. All right. So which means it cuts at negative 1, which is the y-intercept. Okay. And the gradient is 4. So both of them have same gradient, which is 4. Okay. Number 2. Step number 2, find C. All right. In this case, it's easy because they told you the point passes through 0 and negative 3. So you can instantly know that C is equals to negative 3. Okay, but for video purposes, we're going to be proving it step by step so that you can see how to look for C in other case that y-intercept is not given. Okay, so step number 1, y is equals to 4x plus c. Okay, the new y, this is the equation of D. Okay, so you know that they have same gradient, so y equals to 4x plus c. At this point, considering you still don't know what is the y-intercept, we're gonna be looking at it. Okay, so number 2, line D must pass through the point 0 and negative 3. Okay, which means sub x equals to 0, y equals to negative 3 into the equation. So you will get something like negative 3 equals to 4 times 0 plus c, which gives you the same equation, the same answer, c equals to negative 3. All right, so I can modify the question such that the line passes through 1 and negative 3. So in this case, negative 3 is no longer the y-intercept point. So you need to sub 1 and negative 3 here, which in this case, you will get c is equals to negative 7. All right, so it will be a totally different equation. But for this case, let's follow this one. Number 3, you get the answer y equals to 4x minus 3. Easy. So this means that this line D right here is y equals to 4x minus 3. All right. Since they are parallel, the gradient is always the same. The difference is just the height of the slope is different. And this is how you look for the equation of a parallel straight line from a given line. Okay, and we are now moving on to the last agenda for today, and also the last section of chapter 3, which is to look for perpendicular line. So what are the characteristics of perpendicular line? Perpendicular line intersects, the first characteristics, they intersect okay, I'm gonna say in that way. A perpendicular line has a 90 degrees intersection. Okay, what does this mean? If we're gonna draw a simple diagram, this is line A and this is line B. Okay, their intersection point must be 90 degrees. All right, 90 degrees. All right, just in case you can't see that it's a kind of like a square thing. Yeah, so when 2 points intersect each other with a 90 degrees in between, they are perpendicular lines. So the first ever thing that you see the word perpendicular lines, the number one formula that must come up to your mind is MA MB is equals to -1. All right, I'm gonna be pretty honest with you. I don't know the real reason of this equation, and I didn't look for it. Why? But I just memorized it. Okay, so if you would like to know the origin of this formula right here, you can go on Google. But trust me, you would just want to memorize this thing because it's just the gradient of A and B, multiply them is equals to -1. All right, because they are different. Okay, so just a little small thing here about gradients. So gradients, we have a positive gradient, then your line will look something like this. All right, because as x increases, y increases. Right, this makes sense. Negative gradient goes the other way around, which is like this. So if x increases, y decreases. All right, so this is a little small thing about the gradients, and this might be the reason why MB is equals to -1. But yeah, just memorize it. Okay, so you see the perpendicular word, then the first formula that will come up to your mind is the gradient of A multiplied with the gradient of B is equals to -1. Okay, and all the other steps are the same to look for an equation of a straight line. Okay, so I have the first small example here, also from the syllabus. The syllabus, the thing that says what you guys need to know. Find gradient of line perpendicular to y is equals to 3x plus 1. Okay, so every time you see the word perpendicular, the first formula that comes up to your mind is MA MB equals to -1. So in this case, the gradient of A, by interpreting the straight line formula, is 3. Therefore, 3 multiplied with MB is equals to -1. That gives you MB is equals to -1/3. So you get the gradient of the new line, which is perpendicular to y equals to 3x plus 1, is -1/3. It's just that easy. Okay, so we have an ultimate boss level right here, stated in the syllabus, and which I think if you understand this right here, you are pretty much good to go for this chapter. The question is, find the equation of line perpendicular, sorry, I'm just lazy, all right, perpendicular to one line passing through 1, 3, and -2, -9. All right. So how do you look for, and oh, what did I do? Okay. How do you look for the equation? So step number 1. Before that, let's interpret the question, all right? You need to find the equation of line that is perpendicular to the original line that passes through these two. Okay, so in diagram terms, you're not looking for the line which passes through these two. You're looking for the one perpendicular to it. Okay, so if we are going to be drawing it out for easy reference, 1 and 3 is somewhere here. -2 and -9 is somewhere here. So why do they like negative so much? I have to redraw my diagrams. Okay, something like this. 1, 3 is here. -2, -9 is here. So this is the original line given, but this is not the line that you want to look for. They want you to find the equation of line that is perpendicular to the line of this, which means it is 90 degrees. I should not have cut at the origin, which is around 90 degrees like this. And this, the intersection point, will be the midpoint. All right, so this is one thing that I forgot to mention just now. Okay, I'm just go back for a while. Perpendicular line has a 90% intersection point. Number 1, MA MB is equals to 1. And the second one cuts through midpoint. All right, so this thing right here is the midpoint of AC. So if you are given two lines and the midpoint is the same, then you can suspect they are perpendicular lines. All right, very vague, but it might be, right? So this is the line that you want to look for. Okay, so first thing first, we're gonna be writing out our step 1. Find the M of A. Okay, this is A, and B is the one that you want to find. Find the gradient of A. So gradient of A is easy. It's just y2 minus y1, which is -12, divided by x2 minus x1, which is -3. And in this case, you get 4. Okay, this is MA. So after you get MA, you will need to find MB. MA, MB is equals to -1 because they are perpendicular. Therefore, you get MB is equals to -1/4. It's just that easy. Okay, so step number 2. Oh no, I'm sorry, I forgot to change the colors, but it's okay. Step number 2, find midpoint of line A. Okay, so the midpoint of line A is basically the midpoint of these two, right? So 1 and 3, -2 and -9. So 1 plus -2, which is -1, divided by 2 is -1/2. Okay, it's just that simple. Midpoint is equals to -1/2, and 3 minus 9 is -6. -6 divided by 2 is -3. All right, you can double check with your calculator. Okay, so this is the midpoint that we get. So for this part right here, we already found that this equation right here, y equals to 4x plus something c, okay, because that, as you can see here, MA is 4 and MB is -1/4. So MB is something like this. where's the midpoint? -1/2 and -3. So -1/2 and -3 will be somewhere here. So if I'm going to be redrawing my diagram so that it makes more sense to you, okay, okay, and this is line A, and this will be line B. Still doesn't make too much difference, but let's consider this is the midpoint, okay, and they cut in the 90 degrees. So now you have gotten all the requirements needed, okay? You have the gradient, you have 1 point, okay? So it's either you need 2 points to look for the gradient and use one of the points to form the equation of a straight line, or if you have 1 point and 1 gradient, you can form the straight line already, okay? So A is what we are not interested in, but B is the one that we are interested in. So equation of B, up to now, you have y is equals to -1/4x plus c. Okay, so step number 3, look for c, right? Just look for the c. Given midpoint is equals to -1/2 and -3. Okay, just sub these two values into it. You get -3 is equals to -1/4 multiplied with -1/2 plus c. Okay, therefore you will get something like, I'm just gonna press calculator for this, -3 minus 1 divided by 8, you will get -25/8. Okay, therefore you will get your final answer as y is equals to mx plus c. All right, and as you can see from your diagram here, your y-intersection should be a negative, so it makes sense, and the gradient is negative because it's a downward sloping line. So this is how you look for a perpendicular line, okay, given 2 points from the original. Okay, so this can be the hardest that they can ask in IGCSE for you to about this chapter. So make sure if you understand this, then you are pretty much good to go. Okay, I don't think they can get any more harder than this, or maybe they're gonna be saying the length of midpoint A to M is let's say 3 units, and from B to M is 3 units, and they give you the coordinates of A. So in one term, you're gonna be looking for the coordinates of M in another way. So it's like they give you the length, and you're gonna be looking the coordinates of M. Yeah, so yeah, that's pretty much the video. Yeah, this is the end of the video and also the end of chapter 3. It's just a short 2 videos chapter, and in the next video we're going to be going into chapter 4, where we'll be looking at a lot of angles problems, and this is one of the very interesting chapters, and I hope to see you guys next time. Thank you.